So in this case, we are going to consider a typical exam revision for our paper 2, which is for our grade 10, which was written in June 2024, which is also of the Gauteng province. We had the paper 1. So I definitely, I actually think, guys, we did best out of what we had from those revisions, and from what you wrote. I just expect that it was nice from what we had. So if there's anything, if guys, maybe we have the paper that you actually wrote, you can send me the soft copy so that we can have a revision. Maybe you are someone who want to actually know how you did in terms of the paper 1, even the paper 2 that you're going to write. Okay, you can send me that one so that we can have the revision together. It is very, very important for you to know how you answered the questions as a preparation for your term 3. Remember, term 3, guys, it is all about term 1, term 2, just like what we are seeing here in term 2. So without wasting your time, guys, let us quickly rush through our questions. Make sure that you round off your answers to 2 decimal places unless stated otherwise. On question number 1, we are given in fig below. A is given and also the point B is given. These are points on line segment AB. Okay, so this is what we are given according to the diagram, according to the figure that we have. And on this figure that we are given, 1.1, it was to determine the length of AB. So remember that the length of a line can be determined if we are given AB, guys. The length can be determined from the square root of the x values. So someone can use this formula, x1 minus x2. You can use according to A and B. Someone can write this as XA, XB. It's up to you guys. The way that you're going to write, you can have it as x2 minus x1. It is also up to you, the way that you want. Okay, plus y1 minus y2 squared. So like I said, it can be x2 minus x1 squared. It can be y2 minus y1 squared. So this is it. I'm just going to name my points at A. This is x1, y1. This is x2, y2. So according to this formula, I'm going to substitute x1, which is minus 5, x2, which is 4. So that's minus 4 like this. I'm going to square this, plus y1, which is 2, minus y2, which is minus 2. So that's minus minus like this. So remember, a negative and a negative will give us what? A positive at the end. So that was going to give us the square root of negative 9 squared, which is 81, plus 2 plus 2, which is 4 squared, and that's 16. All right, so adding these two, 81 plus 16. All right, let's see what are we going to have there. That is 97. So that was going to give us the square root of 97. That is it. So I've got the length. We can simplify it as a decimal, all right? The square root of 97 as a decimal, that is this one, 9 comma, let us shift 6, then press 2 to 2 decimal places, 9,85. So you can have it as a decimal as well. It is up to you. Determine the midpoints, all right? The coordinates of the midpoint of AB, all right? From the point A that we had, if we are to consider the midpoint of AB, in this case, we simply have to add the x values together, x1 and x2 over 2, the y values together, just like this, y1 plus y2 over 2. So that's the midpoint of a given line. So meaning to say, for the x values, as we had the x1 here, which is minus 5, and this one, which is what? Which is 4. So that is minus 5 plus 4 over 2. The y values, okay, this one, which is 2, and this one, which is what? Minus 2. So we add 2 plus minus 2, everything over 2. So that was going to give us the midpoint of AB. Okay, that's minus 1 over 2. That's minus 1 over 2. This one was going to give us 0 over 2, which is what? Which is a 0 like that. So that is it. We have got the midpoint of what? Of AB. So the midpoint of the line AB was going to be minus half as we had it versus a 0 like this. All right, determine the gradient of AB. So the gradient this time is the change in y over the change in x. So the gradient of AB, I'm just going to use the small letter. That's y2 minus y1 over x2 minus x1. Or you can use y1 minus y2 over x1 minus x2. It's also in your hands. Already we've got our points, guys. Y2, that's minus 2. Y1 is what? Is 2. So that's minus 2 minus y1, which is 2. Over x2, our x2 here is what? That's 4. Our x1 is minus 5. So that was going to be 4 minus 5. So that's it. Minus 2 minus 2, that's minus 4. Negative and negative. Remember, that's a positive. So that was going to give us 9. Just like that, we are done. So we have got the gradient of AB, minus 4 over 9. All right, moving on to another part of the question, which is 1.4. The point A undergoes a certain transformation to the image of A, such that the gradient of the line of that A, image of AB, becomes undefined. Describe the transformation that maps A to its image when the gradient is what? Is undefined. All right. Remember the gradient. Okay, let's go back to what we have here. The gradient is undefined. Guys, what can make this gradient of a certain, because A is being transformed to a certain image. We do not know where it's going to be here or where, but wherever the image of A is, if we are to find the gradient of the image of A and B, meaning to say B is still as it is, B here is still as it is, the gradient is supposed to be undefined. All right, the gradient of a line to be undefined, remember the gradient, the change in y over the change in x. So we have a fraction there, meaning to say x is supposed to be equal to 0. The x values, the denominator is supposed to be equal to 0 for it to be undefined. So where do we have the x values that do not change? That is when we are having, is it a horizontal line or is it a vertical line? When the x values are the same, it is on a vertical line. So when this line here becomes a vertical line like this from the B, because B is not changing, remember, it is A which changed. B is not changing. So A changed. We do not know where it is going to be, but A is going to change in a manner that it becomes from that image of A to B like this, it becomes what? A vertical line, because on a vertical line, the gradient is undefined since the x values do not, x is the same. Remember, if we are at this point B on a vertical line like this, x is the same. X here, it's 4. So it means at that point, x is going to be 4. So when you have got something like this, 4 minus 4, it's what? It's a 0. So that is the case. The denominator, when it is equal to, we are not worried about the y values, the denominator. So the question is, how can we transform this A to where it is to be where it is or where it can be a vertical line? How many units are we going to move? That is the concept. So if we take from A here, how many units are we going to move until we have our image here so that it becomes vertical? So definitely it must be at 90. So this must be a horizontal line, this one. So how many units? You work with x values. It's minus 5 here. The x value here, it's 4. So the difference between these 4 minus 5, that is 9. So we moved the 9 units from minus 5. We moved 9 units up to image in a horizontal. So that's a horizontal transformation of 9 units. Where are we going? To the right. That is the concept there. So that was a horizontal transformation. All right, so 1.4. That was a horizontal. Guys, I don't know if you're together there. Horizontal transformation. A horizontal transformation, 9 units to the right. Of what? Of 9 units. Of 9 units to the right. This is the transformation that you're answering. So the question, guys, was we need to have the gradient of the image of A and B, the image of A and B, for it to have a gradient which is undefined. The denominator must be 0. And that is only, we are talking about a line. It must be vertical like this. When it is a vertical line, the gradient is undefined. So already we see where B is not going to change. So B is going to remain where it is. It is the A which shifted. So you know it's going to be here, but how many units do you move to that point? So you work with the X values from A to that same part, because remember I said it is the same X value. So at A, X is 4. I mean, at this image of A, X is 4. At A here, X is minus 5. So the difference now, that is 4 minus 5. Bigger value minus the smaller value. That's it. Just like that. All right. So that is it on this one. 11 marks. Just like that. We've got 11 marks. Just like that. Question number 2, we are given, if angle A is 78 degrees, B is 34, calculate the values of the following expressions. Correct 2 decimal places. They just say, use your calculator, guys. Just like that. Use your calculator to simplify the sine of A, which is sine 78 degrees, minus the sine of B, where B is what? 34 degrees. We are not given, all right? The instruction is there, all right? It's there, 2 decimal places. So just use your calculator. You can even evaluate everything at once. Guys, the calculator knows what it is doing. So this is sine 78, right? Close the bracket. Minus sine 34, close the bracket. Remember, I've already fixed my calculator to 2 decimal places. So it's going to give us 0.42. Just like that. We move on to another one, the cube root. That is the cube root, this one. So it is the cube root of sec A. So this is the sec of angle A, the sec of 78 degrees, which we cannot simplify on our calculator. So we need the equivalent of a sec. Remember a sec. Sec of x, it's 1 over the cos of x. If it is the sec of A, 1 over cos of A. So this is 1 over the cos. In place of that sec, it is 1 over the cos of what? 78 degrees. Just like that. So that is the cube root of this part that we are going to have at the end, the cube root of sec, this one. So cube root, shift, you go to the square root. You have got the cube root there. So we need 1 over, so that's 1 over here. You must have your fraction there. All right, so that's 1 over what? Cos, so we're going to have cos 78, close the bracket. As it is like this, our answer is 1.69. So that's it, we're done. Guys, just like that. All right, let's move on to question 2.2, where we are given in this fig below, or in this diagram that we have, there's a point P, which is -2, -1. It lies in the 3rd quadrant, and this R, which is OP, is R centimeters, and this one intersects at O, which represents the origin, this and that. All right, so this is the sketch that we're given, guys. All right, so we're given the length of OP, which is R, this one. The point P is -2, -1. Remember the X value, it simply means going straight. The X value is what? -2 at this point. Going down, the Y value is -1. So it simply means the length of this whole part is what? Is -2. Is 2 units, which is -2 because we're going to the what? To the left. And this one is -1, but it's just 1 unit from the Y value. All right. Anyways, let us see our question. Using the sketch and without using a calculator. All right. The calculator is not there. Without. Calculate the length OP, right? On 2.1 or 2. All right. Let me write it down. Let me write it down. 2.21. The length of OP, which is this one. So the length of OP, that is the R that we are given. That is from Pythagoras, guys. As you can see, this is a right angle triangle. We know the length here is 2 units. Here it is 1 unit. So we can use our Pythagoras theorem. So OP is equal to the square root of what? 2 squared, which is the X value, plus the Y value. So the X value, that is 2. Don't worry about that negative. It is just showing us the direction to say we are on the left-hand side. Here we are going down, but the units, it is 2 units. That one, it is 1 unit. So that's it. We were going to have our length of 4 plus 1, which is the square root of what? The square root of 5. So they say do not use the calculator, meaning to say we must have our answer in what? In a said form, square root of 5. Then simplify the value or calculate this value, all right, which is from this condition. They're saying the square root of 5 times the cos theta. So let's go back to the diagram. This is the square root of 5. And what is the cos of theta? According to our diagram, remember your SOHCAHTOA. Our SOHCAHTOA. All right, so let's do this. This is our SOHCAHTOA here. So we need cos of theta. So that is the cos of theta is equal to the adjacent over the hypotenuse. What is the adjacent? Our adjacent according to theta, this is adjacent. Remember opposite, hypotenuse. So adjacent is -2 over the hypotenuse, which is what? The square root of 5. So this is the cos of theta. So in place of that cos theta, we are going to substitute what we got, -2 over square root of 5. So this is -2 over the square root of 5 plus 4 cosec squared theta. Remember a cosec squared, it means a cosec on its own. Cosec theta, it's 1 over sine theta. So when it is a squared, it means also a squared. So it means we've got 1 over the sine squared of theta, right? I was supposed to just rewrite that one, no problem. Okay, let me just do this, no problem, guys. -2 plus 4 into the sine of theta squared. So this is like 1 over the sine of what? Of theta, of which we can just use the cosec squared as it is. Remember, guys, there's so many ways. Okay, no problem. Let me just finish the way that I have just started. Here, the sine of theta. What is the sine of theta? Opposite over hypotenuse. So the sine of theta is the opposite, -1 over the hypotenuse, square root of 5. So this is what we have. We are going to have the sine of theta squared, -1 over the square root of 5 squared. That is what it means. So this was going to give us -2 plus 4 into, let's simplify this one, 1 over. So we have to get rid of this one. So that's -1 squared. So it's 1 over -1 squared, which is 1 over the square root of 5 squared. It's a 5. So that's 1 over 5 there. So remember, 1 over A over B simply gives us B over A. You interchange that. So 1 over this one is simply interchange. It was going to give us what? It was going to give us a 5. This one. Or just use your calculator, guys, like this. 1 over like this, and open a bracket, 1 over a 5. Then close that bracket. It is going to give us a 5. All right, so that's 4 times what? 4 times 5. So this is it. From this one, we can just simplify straightforward. That is 20 here minus 2, which is what? Which is 18 at the end. So that is how we're going to evaluate this one. Just like that. So guys, here's just like a play, like what? Do revise as many questions as you can. Then evaluate without using a calculator. This one, it has nothing to do with that diagram that we had. It is on its own. Just want you to know the special angles. But remember, guys, I talked about the special angles. I said, actually, there is nothing that is very, very important about these special angles, because you know, guys, if you have got this triangle here, the cos of 45 can be used, which is the same as what you have on your calculator, the sine of 45, this and that. So here they are testing you guys. Do you know these simplifications? Do you know the sine of 45, the cos of 45 from what? From your special angles. Without using a calculator. You can even use this diagram, guys. You can even use your calculator. No one is going to know that you have used a calculator there. So what is the sine of 45? According to 45 degrees, you just use 1 there. So remember, sine opposite over hypotenuse. So opposite 1, hypotenuse is what? Is 2. So that's 1, the square root of 2. So if you use your calculator, it will give your answer as square root of 2 over 2. It is the same as this one. 1 over square root of 2, it is the same as square root of 2 over square root of 2 over 2, like this. It is one and the same thing. It is one and the same thing. So the sine of 45 degrees here, sine of 45 degrees is equal to 1 over square root of 2, which is the same as this one, square root of 2 over 2. So instead of writing 1 over square root, let us just write square root of 2 over 2. That's why I'm saying, even if you use your calculator, guys, no one is going to know that. What they do not want is for you to simplify everything like that at once. All right. So let us move on. This square root of 2 over 2, as we can see, is going to remain as it is, times the tan of 30 degrees is squared. So the tan of 30, there is another diagram that we're going to need where the 30 degrees is. So from our special angles, or you can just use our calculator, like I said, no one is going to know that one. So if this is 30 degrees, this is 60 degrees, this is 1, this is 2, and this is square root of 3. So where you've got the 30 degrees, tan, SOHCAHTOA, opposite over adjacent, opposite, and this is our adjacent. So that's 1 over the square root of 3. So this is what you're going to have, of which 1 over square root of 3 is the same as the square root of 3 over 3. If you're using the calculator, you can have it like that. One and the same thing. That is the tan of what? That. So this is the square root of 3 over 3. Everything is being what? Squared. So that's it. This part and this part stem. This can cancel. So we've got 1 over what is going to remain in the numerator. So that's 1 over the square root of 3 squared. Square root of 3 times the square root of 3. This will give us what? A 3. Over what? 3 squared, which is 9. So remember that part that I was talking about, 1 over a fraction. Interchange that fraction. So it's 9 over what? 9 over 3, just like that. So that's 9 over 3, which is equal to what? 3. So that is what you're going to have at the end. So guys, it is like just a play, but just revise as many questions. On question number 3, we are given 2 sketches. The sketch of f of x, which is cos of x. So this is cos of x. And the other one, the g of x, which is 2 sine of x. So this is what we're given from 0 to 360 degrees in that interval. So the question was on 3.1, determine or write down the period of what? The period of g. So if we are to consider, this is our g, guys. What is the period of g? So the period of g is what? 360 degrees. Nice. This one was direct question, isn't it? So this is 360. There are no changes there on the graph of what? Of a sine. 3.2, the values of x. The value or values of x for which f of x is greater than or equal to 0. F of x, this is our f. This is our f, this one. This one. So when it is greater than or equal to 0, measure it from this one. From the horizontal, that is where you measure, because in the horizontal, in the x-axis, that is where y is equal to 0. So they're saying, where is it that our graph is greater than, it is above the x-axis, the graph of f. So the graph of f is above the x-axis. If you check here, the graph of f, it is above the x-axis from here to here. It is above the x-axis. And from this point here, it is above the x-axis. So as you can see, it's an interval from, in terms of the x, 0 degrees to what? To 90 degrees. So that's from 0 to 90. You're going to have as x is greater than or equal to 0, but less than or equal to 90. And because there's also another one, or also from this region, we saw from 270 to what? To 360. From 270 to 360, x is greater than or equal to 270, less than or equal to 360 degrees. All right. Then determine the range mx if mx is equal to this. So remember, range are the y values. When you talk about range, you talk of the y values. So you can have it automatically from here. If mx is given as minus 4 times f of x, what is the range of f of x? So that's minus 4 times the range for that f of x. If we are talking about the f of x, guys, our f of x is taken from where to where? That's our f of x. Remember, this is our f, this one, our f of x, this one. It is taken from where? The negative, -1 up to +1. This is our f of x. From -1 up to +1. So our f of x is taken from -1 up to +1. So we multiply this. But after multiplying, we are supposed to add the one that we are seeing. That is the new range. Just like that. You answer according to that. So -1 times this is going to be positive. -4 times -1. This one and this one is going to be positive. Negative, and this is going to be -4. All right. Then we add 1. So 4 plus 1, that is a 5. We add 1 minus 4 plus 1, that is -3. But we can't write this way, guys. Like, we have to interchange. As we can see, -3 is less than 5. So we're going to start with what? With -3. So therefore, in this case, y is going to be taken from -3 up to what? Up to 5. We start with a smaller value. That is it. Or, guys, you can have the way that you understand. I don't know. So many ways of answering this type of a question. So many ways. This is a revision, guys. Make sure that you go through introduction so that you understand much, much, much better. Question number 4, we are given this diagram. And in this diagram, we are given A is the angle theta. And we've got 90 degrees here, the right angle that we can see. BC, X centimeters. Angle C, it's beta. So this is our angle C, and they've got a 90 degrees there. All right, no problem. From there, show that AB can be written as X sine beta over tan theta, AB. All right, where is AB? This is our AB, this one. AB can be written like that. All right. So as we can see, in AB that we are given, it carries, all right, X sine beta. Let me write it down. X sine of beta over the tan of theta. Over the tan of theta. As we can see, it carries X and beta. X and beta are from this triangle. So there's no way, guys. We must work from this triangle and find something that has to be part of this triangle where AB is. Because in AB, or in AB, this triangle, there's nothing that we have, only angle theta and the 90 degrees. So meaning to say there's no way, we must work with the triangle BCD to find one of the sides, which is in this triangle. And that side is what? Is BD. All right, so let's work from that way. From triangle BCD, from triangle BCD, find what? Find BD. So to find BD according to beta, this is the opposite, and x is the hypotenuse. We must find this in terms of x, remember? So meaning to say, BD is going to be like this, where we have got opposite and hypotenuse, the sine from our soccer tower. So the sine of beta is equal to the opposite over the hypotenuse. What is our opposite? That is the BD, all right, over the hypotenuse, which is our x. So remember, we want to find BD. So let us cross multiply this same as over 1. So we're going to cross multiply to find BD. 1 times BD, that's BD is equal to x times the sine of beta, which is x sine of beta. So wherever we see the BD, this one, we are going to have it as x sine of what? Sine of beta, like this. So that is what we're going to have. Then from there, we can find our AB in this triangle, what? In triangle ABD. So now we can find AB in triangle, what? In triangle ABD. So using triangle ABD, AB here is the adjacent, as you can see. And according to theta, now you're talking about, remember we talk about theta. Theta is the one that is controlling now. So according to theta, this one still remains as the opposite. So BD, the one that we're given there, is the opposite. Remember we calculated BD. So we're going to use the tan. So the tan of theta is equal to what? Remember from our soccer tower, tan opposite over adjacent. What is our opposite? That is x sine of beta over the adjacent, which is the AB in this case. Remember, we need to calculate or to find AB. So let's cross multiply so that we can have our AB. So if we cross multiply, it was going to be AB times the tan of theta, all right, which is equal to 1 times this part. It is going to be x, the sine of what? Of beta. So to find AB, we're going to divide by the tan. Since that's a product, so divide by tan theta, divide by what? By tan theta both sides. So this was going to cancel. So that was going to give us AB, which is equal to x sine of beta over the tan of theta. Just like that. So this is exactly what they wanted you to prove or to show that it was equivalent. So you have to work from this triangle, you find this, work from another one, just like that. Then from there we are given, hence or otherwise calculate the length of AB, correct to 2 decimal places. If we are given theta as this, beta and x is also there. Write down your answer to the nearest whole number. Guys, already we have this AB, so simply substitute. AB is equal to x. What is our x? 12. So that's 12. Sine of beta. What is our beta? 40 degrees. Everything over what? The tan of theta. What is our theta? 52 degrees. Just like that. This is what they say. This is what they mean. So find AB from there. So you can simply use your calculator there. A fraction, that's 12 sine 40 degrees. Okay, close that bracket over what? The tan. So this is tan of 52 degrees like this. So it was going to give us 6,03 and so on. But they say to the nearest whole number. So to the nearest whole number, if we look at this, the next digit is 0, which cannot change this 6. So it will remain as what? As 6. So AB was going to give us 6. Remember, x is in meters. So it also means our AB is going to be in what? In meters. This is the length. So you use the length from the unit that we are given before. So that was it, guys, just like that. On question number 5, complete the theorem. The line segment joining the midpoints of 2 sides of triangle is, and the line segment joining the midpoints of two sides of a triangle, if these are the midpoints, a line segment that we draw is what? This line segment, it is parallel to this one and half in length, all right? So it is parallel and half, all right, and half in length. So this one is this half in length of the third side of the second one. Okay, that is from this one, the second one. That is how we work out the midpoints theorem. 5.2, we are given if this is a rhombus that we are seeing here, and we have got the sides AC, the wall of this side AC is 16, the BD is 30 centimeters. If this is a rhombus, remember the properties of a rhombus. So they are saying calculate, all right? There's another part. Let me check here, the first one. So the first question was to calculate the length of BC, all right? From B to C, this one, from B to C. All right, so guys, remember the properties of a rhombus, guys, that these diagonals, they bisect each other at a perpendicular. They are perpendicular, actually. They bisect each other at 90 degrees. So there we can use the Pythagoras, because AC, the whole of this AC is 16. The whole of AC. So half of that one from A to O is going to be 8. From O to C, it is going to be 8, half of 16. If the whole of BD is 30, divide by 2. So meaning to say, if we divide this one by 2, this will be 15, this will be 15. So to find the length of what? The length of BC, we can simply use this triangle, because it is a right angle triangle, like I said. And thus Pythagoras theorem can be what? Can be used. Because BC squared is equal to OB squared. So that will be OB squared plus OC squared from our Pythagoras theorem, meaning to say BC squared is equal to 15 squared plus 8 squared, just like that. So that is going to be equal to 225 plus 81, which is going to give us 289, and that will be BC squared. To find the BC, introduce the square root. So that's BC is equal to square root of 289, which is 17. So that's 17 units, just like that. So we have it. So remember the properties of a rhombus, that these sides are actually the same throughout. We could have used this side, so it also 17 is also 17 is also 17. Remember those properties. So that is what you are given. And 5.2, it is calculate the length of OF. If OF is parallel to DC, all right? OF, where do we have this one? OF, this is where we have our OF, this one. It is parallel to DC. These two, they are parallel. And not just only parallel. With F on what? On BC. All right? These two, they are parallel. F is on BC like this. All right, remember, let us go back to this part. Because this one, what are we forming here, guys, is a triangle from B to C to D, back to B like that. It's a triangle. Let's go back to this theorem. We talked about what? The midpoint. If you are joining to the midpoints, the lines will be parallel and the other one will be half in length. This is exactly what we have. These two lines, they are parallel. So it means OF, this OF that we are seeing here from our midpoint theorem, it is half of CD or DC. That is it. So it is a half of what? Of 17 units. So that's 17 over 2, or 17 divided by 2, which was going to give us 8,5. So that's 8,5 units from the midpoint theorem. So you see, guys, those theorems, they now play a role. Determine the size of OBF if we are given OFC is 64. OBF. Where is OBF? From O to B to F, this angle here. Determine this angle if this angle OFC is 64. OFC, OFC, OFC. All right, if this angle here is 64, what about angle B1, this one? All right, what can we do, guys? How can we play around with this type of a question? Remember, these two lines are parallel. So let us try to work with the properties of parallel lines, okay? Let us try to work with the properties of parallel lines. The angle, okay, that one is not gonna even help. All right, let me do this way. I have a lot of things. If I do this way, I can properly see. All right, this one is 64, remember? We need this angle. All right, remember that is the midpoint concept. This one is a midpoint. If it is a midpoint, like if this point F and point O are midpoints, if these are midpoints, it means OD and BF will be equal in length. Remember, I'm saying these are midpoints. Midpoints, like, all right, it is me now who is writing this way in a wrong way, guys. O is the midpoint, so it is like this. These two are equal. These two are equal like this. This is the midpoint concept. So if we consider this properly, we are going to notice in terms of our triangles, all right? If we consider the angles that we have, the triangle that we formulated here in terms of the sides, right? Let me bring it. You understand me very soon. Remember, this is 15. All right, I'm not even supposed to explain a lot of things like this, guys. Remember, this one is what? It's 15 here. And this one is what? It's 8 here. And that was, we calculated this one. But if we are to consider these sides, they do not have anything to do with our sides. But what they help us is knowing in terms of the angles to say this length here is the same. Yeah, this one, the length of AB. From this one, we calculated, no problem, but just know that these two are equal, 8.5. Equal in length and also parallel. Equal in length, also parallel. So the equal in length, don't put it as a reason. This one, I'm just explaining the properties of a rhombus. The parallel concept is the one that I want here. If these two lines are actually parallel, AB and CD, they are parallel. It means AB is also parallel to OF. All right, let me write this one. I need to write. I have talked about a lot of things. And some of these things, they are not necessary to answer my question. Like I said, guys, I'm just like explaining some of the properties of a rhombus that you do not even need to answer this question. Let me write what you need. So one thing, if, right, so this is 5.23. If CD is parallel to OF, therefore, AB is parallel to OF. Because we have this one before, AB is parallel to CD, a rhombus, from the properties of a rhombus. So CD and OF, they're parallel. So it means AB and this one will be also parallel. So now let us consider these two being parallel. What is happening here on these two? If they are parallel, it means the whole of this angle OF to C, this one that we formed, considered to the angle B1 and B2, they must be equal. Guys, these two lines, we are saying they are parallel. These two. So the 64 degrees, all right, we are now almost there. It is like this. Focus with the 64. Focus on the 64. So it's like this now. These two lines, they are parallel. The 64 degrees is here. So this whole angle must be 64 degrees, meaning to say the whole of angle B combined together must be 64 from what? Corresponding angles. The whole of angle B, angle BC, must be equal to 64 degrees, which is the angle F1 that we are seeing there from that one that we are given before. We're talking about corresponding angles there. All right? Corresponding angles, since we are referring to AB parallel to OD. AB parallel to OF. So this angle, if it is the same here, if the whole of this angle is 64, what about angle B1? That is the question. What about that one? Remember what the diagonals of a rhombus do. Guys, you must know your properties. There's no way you must know your properties. You answer this question with property. We now know that the whole of this angle is 64. Then the diagonal of a rhombus, this one, it bisects that angle. The diagonals of a rhombus. So B1 and B2, they are equal, remember, from the diagonals of a rhombus. Angle B1 is equal to angle B2, diagonals of a rhombus here. Diagonals of a rhombus. So the diagonals of a rhombus bisect what? Bisect angles. So this one, they do bisect angles. So meaning to say, these two are equal. Remember, the angle B, this one, angle BC is made up of angle B1 plus B2. It is angle B1 plus angle B2, which is the 64 degrees. And we are saying these two, they are equal. So we can have it as 2 angle B1 is equal to 64 degrees because they are equal. So divide by 2, that's what? 32 degrees. So it means angle B1 is equal to angle B2 is equal to angle 32 degrees. Angle B1 is the angle that we need, which is the angle represented as OBF. Our angle OBF is our angle B1. So that's our angle OBF. Just like that. So you must know your theorems, guys. Know your theorems. Work with theorems. Work with theorems. The area of the rhombus ABCD, all right? The area of the rhombus ABCD, the whole of this rhombus that we see, all right? So the area, guys, there are so many ways also. We can work with one triangle here, then times 4, because it is made up of this way. Let me do this. 4 identical triangles. This triangle here, we calculate its area, then times 4. Remember, this is 15 and this is 8, and it's a right angle triangle. So we just calculate that one, then times 4, or, okay, let me have this one first. So there are so many ways. So area of a rhombus, which is 5.3. So area of a rhombus is going to be 4 times area of one triangle. Area of one triangle. So meaning to say that is 4 times area of one triangle is half times base. Remember, half base times perpendicular height. So it's half of 8 times the perpendicular height of what? Of 15. Just like that. So that is half of 8, which is 4. 4 times 15, which is 60. Then 60 times 4, which is 240. So that's the area. Or we can use this product, half of the product of the diagonals. Another way of finding area is half product of diagonals. Half product of diagonals. The diagonals are the ones that we are given here as they are. So it is half of 16 times 30. As it is like that. As it is. As it is like that. Half of what? Half of 16 times 30. As it is. So that's 240 again. So as we can see, we have got the same answers there. So these are the typical questions that you might be given. Just make sure that you go through as many questions as you can. Try to revisit your term 1, term 2, everything that you did, all the basics of your paper 2. Prepare yourselves for the exams that are ahead of time. So that's it, guys. Till we meet again.